Good morning to all students. So today I am going to explain the Model 2 uniform flow in a open channel hydraulics. So firstly, classification of the flow in the open channel. The different classification of the flow in the open channels are steady and unsteady flow. Second one, uniform and non-uniform flow, laminar and turbulent flow, and subcritical, critical, and supercritical flow. So, firstly, steady flow and unsteady flow. Steady flow can be defined as if the flow characteristics such as velocity and rate of flow at any point in open channel flows does not change with respect to time, then the flow is said to be steady flow. Mathematically, dou u by dou t is equal to 0, dou theta by dou t is equal to 0. Then unsteady flow. If the flow characteristics such as velocity and rate of flow at any point in a open channel flow changes with respect to a time, then the flow is said to be unsteady flow. So mathematically, dou e by dou t is does not equal to 0, dou theta by dou t does not equal to 0. Second one, uniform flow and non-uniform flow. Uniform flow. For a given length of a channel, the depth of the flow, slope of the channel, and the cross-sectional area remains constant, then that type of flow is said to be uniform flow. Mathematically, it is expressed as dou by dou s is equal to 0, dou v by dou s is equal to 0. Then non-uniform flow. For a given length of the channel, the depth of the flow, slope of the channel, and the cross-sectional area will change. Then that type of flow is said to be non-uniform flow. So mathematically it is expressed as dou A by dou S does not equal to 0, dou E by dou S does not equal to 0. Then third point, laminar flow and turbulent flow. In that laminar flow, the flow in a open channel is said to be a laminar flow if Reynolds number is less than 500 or 600 and it is given by Re equal to rho V into D divided by mu, that is less than 500 or 600, where D is the hydraulic mean depth. Therefore D equal to E divided by P, area divided by perimeter, that is wetted area divided by wetted perimeter. Turbulent flow. If the Reynolds number is more than 2000, then that type of a flow is called as turbulent flow. Therefore, R is greater than 2000. Subcritical flow and supercritical flow. In that subcritical, the flow in a open channel is said to be subcritical if the flow's number is less than 1. It is also called as streaming flow. Therefore, subcritical flow F is equal to V upon root of L upon G less than 1. Critical flow. If the flow is said to be critical flow when the Froude's number is equal to 1, that is Fe is equal to V upon root of L into Z, that is equal to 1. Supercritical flow. The flow in which the channel is said to be supercritical if the Froude's number is greater than 1. Therefore, Fe is equal to V upon root of L into Z greater than 1. So, now one important derivation that is called as Sugges's equation. Derivation of Sugges's equation for uniform flow in a open channel with usual notation, or it may be asked Derive an equation for the discharge in the open channel for Sedge's formula, okay, or discharge in open channel by using Sedge's formula. So this is the diagram in which the flow of the water or a fluid will be taking place. So that is 1 1 and 2 2. Okay, the flow is taking place, and here in between that we will be having W into sine I, where W is the weight and theta will be there. Therefore, consider uniform flow of a water in a channel as shown in the above figure. If the flow is uniform, it means that velocity, area of the flow, depth will be constant for a given length of channel. Therefore, consider a section at 1 1 and 2 2 as shown in the above figure, where L is the length of the channel, A is the area of the channel, I is the slope of the bed, V is the mean velocity of the flow of the water, and P is the weighted perimeter of the cross section, and F is the friction resistance per unit area. Then M is the hydraulic mean depth. Therefore, the weight of the water at a section 1 1 and 2 2 is given by weight W is equal to specific gravity into volume. Therefore, W is equal to specific gravity is W small w into A into L. Resolving the component of a W along the direction of the flow will be given by W into sin I. Therefore, W is equal to W into A into L into sin I. The frictional resistance against the motion of the water is equal to F into surface area into Vn, where F is the friction and surface area in the pipe or in the flow that will be affecting that surfaces, and V is the velocity. Okay, the value of N is found experimentally and is 2 and 2, and therefore surface area is equal to perimeter into length, that is friction resistance is equal to F into P into L into V square. The difference forces acting on the water along the flow direction is given by component of the weight of the water along the flow direction and the friction resistance along the flow of the water. In the case of a uniform flow, the velocity of the flow is constant for a given length of the channel, and there is no acceleration acting on the water, so that the resultant force acting in the direction of the flow should be zero. Resolving all the forces in the direction of the flow, therefore W into A into L sin I minus F into A into L into V square is equal to 0. Further simplification will find V square is equal to omega into A into sin I divided by F into P. Okay, then further simplification will get V equal to root of W into F into P divided by E divided by P into I, where root of W by F is equal to C and A by P is equal to mean hydraulic mean depth, where C is equal to such is constant, therefore V is equal to C into root Mi. J and discharge is equal to Q is equal to A into V, therefore Q is equal to A into C into root of Mi, that is discharge. This is the Sajji's equation derivation. So one problem is there. Find the velocity of the flow and the rate of the flow of a water in a rectangular channel of 6 meter width and 3 meter depth where it is running full. The channel is having bed slope in 1 is to 200. Take this constant C as 55. So therefore this is a rectangle channel of 6 meters and 3 meters. Therefore area is 6 into 3 18 square meters. Then I suggest constant is I is the slope, that is 1 upon 200. Therefore B is equal to C into root f of I and Q is equal to A into V as from the previous. Okay. C is 55. They are the defined velocity V and discharge Q. And M is equal to A upon P wetted perimeter M. So A is 18 area, then P is 12, means 6 plus 3 plus 3, that is equal to 12. Therefore P is equal to breadth depth 2 times of the depth. M is equal to A upon P, and therefore P equal to P into 2 times of D, that is 6 plus 2 into 3. Therefore P equal to 12 meters. Using such this formula, V is equal to C into root of M. C is 55, root of 1, M is equal to 1.5 into I is 1 upon 200. Therefore V is equal to 1.5062 meters per second. And we know discharge is equal to area into velocity. So area is 18, and from the above we get the velocity, that is 1.06 1.506.5062. Therefore Q equal to 27.11 cubic meter per second. Similarly, there is another problem. Find the slope of the bed of a rectangular channel of a width 5 meter, depth of water is 2 meters, and the rate of flow is given as 20 cubic meter per second. Take such as constant C is equal to 15. So for area is 5 into 2, 10 square meters. Then discharge Q is equal to 20 meter cube per second. M is equal to A upon P. C is equal to 50. I is equal to, they are to find slope I. So we know that P equal to D plus B plus D, that is equal to P is equal to B plus 2D. Therefore 5 plus 2 into 2, 5 plus 4, that is P is equal to 9. M is equal to A upon P, area divided by weighted perimeter. Area is 10 and P is 9. Therefore M is equal to 1.111 meters. We know that V is equal to C into root of Mi, that is equal to into 2 is equal to 50 into root of I into M, M into I. M is 1.11 I. You have to find it. There 2 divided by 50 is equal to root of I into 1.11. 2 divided by 50 square is equal to I into 1.111. Therefore I is equal to 2 divided by 50 into square into 1 divided by 1.11. I equal to 1.444 into 10 to minus 3, and therefore I is equal to 0.004. Therefore I is equal to 1 upon 694.45. Therefore I is equal to 1 in 694.45. Okay. So similarly we can go for another problem is there. Okay, and this I will be sending as a PDF, and if any doubt you can ask. Okay, thank you.